Pleasure to introduce my friend Carole Goble. And as I was doing my research for this introduction, I realized that in the last few years, Professor Goble got a new title, and I am to call her now, and all of the rest of you as well, Commander Goble. She was given by the Queen, the Commander of the Order of the British Empire, the CBE. So I know when you listen to the charges that Carole will give you in this talk, you will all obey them. And you would have anyway, but now she is a commander. So these are commands, not just a talk. Having known Carole for many years, I can attest that she is a force of nature. By the age that most of us were in graduate school as a young graduate student, she was a professor. She skipped the graduate school thing altogether and went pretty much directly from undergraduate to being a professor of computer science, and not too long after that to being the chair of the department. Okay, I don't know about you, but I couldn't have pulled that off even in my glory days. And her work has really been transformative in a lot of areas. She is, I think, probably best known for her workflow tools, for kind of keeping track of all of the things that scientists do with computers on the way to getting to that paper. So early work in Taverna, and then later MyGrid and MyExperiment. She once told me that she thinks of these things by trying to find what a good sticker or a logo would be in order to name them, and that's how she comes up with these. So I've been doing science all wrong, apparently. Anyway, she's a real force for what has become very important topics in rigor and reproducibility that NIH and European science has really focused on. Interoperability and provenance tracking. These are the kind of things that Carole has been working on for her entire career. And one of the reasons I'm so excited for her talk is that she has a history of some of the most amazing talks I have ever seen. Okay, I don't know if you all, probably not too many of you were there for the Standards and Ontologies of Functional Genomics talk in 2004, where she used Romeo and Juliet, the Montagues and the Capulets, to describe the uncomfortable interactions between computer science ontologists and biomedical ontologists. It was brilliant. And then the 7 Deadly Sins of Bioinformatics in 2007, that was a good one. And her the most recent talk I've seen her give was about 5 years ago, where she was giving a talk on what is reproducible that was called Your Results May Vary, which I also thought was brilliant. So with that, I would like to present you with the PSB traditional lei. Both cheeks. Oh. Oh.
Thank you.
Carole.
I have to take this off because I'm going to play around with the microphone. Well, I mean, I'm just going to walk off now because that's just, those talks, well, one of them was in iambic pentameter. You can't pull that off twice, right? That's impossible. And no, I wasn't given my commander by Prince Andrew, for those of you who asked. Yeah, you didn't even chat me up, actually. I'm very disappointed. But I did get chatted up by Prince Philip, who is like 93, but he's a bit of a goer, I can tell you. So anyway, back to that. So what I'm going to talk about is building the fair research commons for life sciences. This is kind of a rambling rant, really. Yes, you can, who is Twitter woman? Yes, you can tweet it, or she's gone. And I'm going to be pretty rude about some things, but then as I'm about to get kicked out of the European Union, who cares? So I can't get any money out of them anymore, so whatever. Okay, so since 1995, I've been building e-infrastructure for life sciences, as Larry said. I've been building platforms for automation, workflows, and so on. I've done a lot of work on semantics, and I've fought in the semantic ontology wars and probably lost. I built platforms for sharing and collaboration. I've built knowledge-driven warehouses and data integration platforms. And at the same time, Pacific Symposium on Biocomputing, 25 years on the Big Island. And I noticed this first workshop or this first session, Internet Tools for Computational Biology, 25 years ago. The Internet makes tools available to researchers, and the burst of the World Wide Web has accomplished to make data accessible on networks. Exciting. URL no longer available, but never mind. And that's a kind of indicator of trying to maintain these things. So back in the day, what were we doing 25 years ago? Well, we were all trying to build the monolithic intelligent database, private shared stores with complicated file names and versioning schemes for our files, hacked up Perl scripts, everybody remembers Perl, point and click, cut and paste between browsers, and screen scraping and small scale processing, and lots of Excel spreadsheets, like the last talk. And papers published without access to the data or the codes, and with lightly described protocols. And what do we have now? Well, we have cloud services and large-scale processing and cloud stores with complicated file names and versioning schemes. We have hacked-up Python scripts with some interactive notebooks. We are now building microservices and stitching them together with standards rather than building monolithic databases. And we have Excel spreadsheets with papers one click away, but access to the data and codes within those papers still missing. But we do have lots of social media. So that's good. You can find the paper even if you can't get the data associated with the paper. So one of the things to remember when I'm building spending my time building these very cool commons and building a complicated e-infrastructure for Europe in life sciences is that most research is still done by small groups in little private collaborations by individual researchers, PhD students, using scripts and file stores and spreadsheets, stressing out their bioinformatics facility, if they have one, and in modest, stressful, and competitive conditions, with institutions that haven't changed their assessment rules. And after 25 years, that's a bit sad. But that's the reality of the context that I'm going to be talking in. I did notice as well that we now have automation, reproducibility, portability, and reuse has appeared in PSB. So there's been reproducibility workshops, and yesterday there was a packaging workshop. So it's good to see that there's now a much more emphasis on software as an entity, software reproducibility, software as a commodity in its own right, rather than just a mechanism of doing the computational biology. Not very much on workflow systems, though. And as somebody who spent 20 years building workflow systems, that's a bit disappointing. But we'll come back to that later. But it's good to see that giving software its due, software citation principles. So software, in the last 25 years, software has become as important, hopefully, as data. And thanks to the French, because you can always rely on the French to be able to secure heritage. We have software heritage, which basically scrapes all GitHubs that it can find, all GitHubs, to build a universal software archive. And we have the first certifications agency for scientific code and data, run by the French. Hurrah. We also have professionalization. So 25 years ago, I don't think there was this notion of a research software engineer, and now there is. There's the International Society for Research Software Engineers. And the notion that scientific software is important as its own research environment, as most important for executing research. This is an old paper from over 10 years ago. Even then, 91% of those surveyed, 1,000 scientists surveyed, said that software was important. And this is the research software engineers. Who's heard of research software engineers? Oh. Who uses a postdoc to write some code for them? Who's given that guy or girl a career path? Good. Excellent. That's what a research software engineer is, and it's really taken Europe by storm. And there is a US drive to build research software engineer teams. So I think this is a very important thing, particularly as I'm married to one. So I'm very vested in this. The other thing that I noticed that we had quite a lot of different workshops on and sessions, interoperability, reuse, metadata, ontologies, standards, things like this. Lots and lots of things on biomedical ontologies, many of which I was actually an author of, which was quite interesting. Standards, activities, and so on. And then finally, the last time I was actually here was for a workshop on open science. So we can see here, there's a picture of me with Cameron Naylan, Heather Poawa, and that looks like Phil Bourne's back there. How could we set an international standard for data availability and openness? And would it be useful to do so? How presumptuous of us to think that we could have an international standard for universal data access. Actually, we established something called Force 11, which is a community for research communications. And in 2019, there's at least 100 networks all working together in open science. What we didn't do was set a standard, but what we did do was enable a principle. And the principle was the FAIR principles: Findable, Accessible, Interoperable, Reusable, the guiding principles for scientific data management and stewardship. So that's one of the things I'm going to be talking about, is this notion of FAIR. And why did we end up with coming up with this idea of FAIR principles? Well, because of data-driven bioscience, because of the usual issue to do with data sharing, because finding stuff, accessing stuff, interlinking it, reusing it should be the norm of scholarship. It's certainly the norm of, or the way that we can drive team science. It's how we do knowledge pooling. And this is my only AI slide, which is AI depends on FAIR. You see, if I was good at PowerPoint, I'd have lifted it up out of the FAIR, but I just couldn't be bothered in the end. But how are we ever going to do any of the AI things that we heard about this morning if you haven't got available data, if you haven't interlinked that data, if that data is not well described, if that data is not available to us and pooled in a way that we can use it to do all our groovy types of algorithms and so on. And then the second thing that has come up since we sat around the pool over 10 years ago is this notion of a research commons. Governed shared spaces where investigators can store and share and access and connect with digital objects, not databases, not warehouses, but places of collecting together resources and organizing them in such a way that we can then have them hosted, we can process them, and so on. So this is not an integrated database. This is a commons, a common place, an infrastructure for sharing and exchange and reproducibility. And this picture is from the National Cancer Institute Research Data Commons that was quite widely developed in the US. I mean, there was a great deal of investment in it. So it's a place where we can do data submission, we can do visualizations, we can do metadata analysis, and we can do data analysis. Why? Because if we can get hold of things, if we can get a flow of information, if we can have available quality resources, we can overcome silos, we can get better organized, we get access to know-how, we get pooling effects. Quality stewardship, long-term responsibility, sustainability. So rather than just relying on the computer underneath the desk, we actually attempt to do some pooling. And one of the reasons why I was most inspired by Commons is Josh Sommer. I saw him talk at a Sage Bio Networks meeting a long time ago. And he had cancer at the time. He had a rare cancer, chordoma. And what he discovered was there was no mechanism of being able to really accelerate the research on his cancer, because there was so little turning of the knowledge between the laboratories able to treat him. And that not just the availability of information, the availability of data, the availability of processing just wasn't there. So he really didn't see that flow of information. And so he took ownership of it and said, if we want new results, we have to improve how we move information between our laboratories, and we have to pool it. So I thought that was quite inspiring. So Bob Grossman has presented this as a technical view for commons, which is this kind of, if you turn this on its side, it's a hourglass. So the idea is a very thin, small number of services for access, for identifier management, for metadata management, and then a whole bunch of tools for being able to get together data, and a whole bunch of tools for being able to process that data, and effectively a market. A market for tools to put things into the commons, the first mile, and for tools to have access to the information in the commons, the last mile. So this is a very much more open approach than to say, I'm going to have an archive, I'm going to have a warehouse, I'm going to have an integrated data set. And of course, it has associated with it all sorts of governance policies and so on. Of course, there's also the social view, and the social view is the people putting together such a commons, the people using that commons, the teams of individuals associated with them, and I've worked a lot with different kinds of teams. It's the techies, the curators, the policymakers, the infrastructure providers, the research software engineers, and if you're working in the health commons, you have other kinds of stakeholders. All of whom are collaborating together in order to be able to do this, and all of whom are competing against each other. So let's go on our commons safari. So there's a whole bunch of commons now coming up. There's the Australian Biocommons. There's the Cancer Genomics Cloud from Seven Bridges, Synapse, various different knowledge portals, the Human Brain Project, Cyverse Data Commons for plants, the Open Science Framework for lots of other people. Then there's Commons Bananas. Now this is where I don't ever get funded by the European Commission ever again, because this is the notion of the European Open Science Cloud, which is we will build one commons for 1.7 million researchers for everything. Let's think about that. Everything. Particle physics, biology, history, everything, social science, and we're all going to have pan-discipline reuse, so that a social scientist can just use any data that you was presented this morning without actually having to worry about being able to have negotiated access to it, or by rapidly being able to understand what that data is about. This is just madness. Universal metadata for all disciplines? No. Commons are always valuable when they are specific. There is no one size fits all. So what I'm mainly going to talk about is elixir. So elixir is a distributed data infrastructure for European life sciences. Larry is honoured to be on our advisory board, which means we give him loads of work to do. And Soren, who's in the audience somewhere, is head of node for Elixir Denmark. I'm head of node for Elixir UK. All of this is my private views rather than those of the community, because I didn't check them out with anybody. And here we are using this idea of FAIR, Findable, Accessible, Interoperable, Reusable, as a general principle to coordinate and integrate resources across Europe, across the member states, 23 countries, over 220 organizations, to enable users to access services and to be a partner in standards and EU programs. What this really is an ad hoc commons. It's not a managed commons in the sense of we have decided to have a specific data model, and we're going to manage very closely who can put resources into it and who cannot. This is actually a fragmented ecosystem of community resources donated from across Europe. Very distributed, many different entry points, each of it independently managed, but we want to be able to coordinate them to work together. So this is really tricky stuff. This is holding this very large collection. The European Bioinformatics Institute's resources are in here, for example. Things like Fair Sharing, which is a catalogue of standards. Identifiers.org, which is our identifier resolution registry. We're holding it all together with standards and metadata markup and common identifiers and workflows and tools. But it's the same architecture. It's the same sort of notion. A very small number of services that we put together for AAI, for access and authentication, and then a whole bunch of different kinds of data sets and a whole bunch of different kinds of tools, particularly workflow tools and notebooks, running over national infrastructures in order to be able to feed the resources needed to be assembled together for different communities. So, for example, for federated human data, we in Elixir have developed the EGA, European Genome Archive, in order to be able to be federated. So we can put one in each country and then federate it in a safe kind of way so that we can manage data, human data, in a safe kind of environment. We also have implemented beacons in order, again, to be able to provide safe sharing for public and private genomic data sets. We built plant phenotyping commons based on standards around the breeding API and MAPI standards around plant phenotype metadata collection. We built a Galaxy as a workflow system, very widely used, and Elixir has adopted this and had Elixir Europe, where we have our own international Galaxy environment for different kinds of workflows, for different kinds of communities. So this is a social infrastructure as well as a technical infrastructure, which is held together by hard work and faith and an enormous amount of politics and lots of travel and an enormous amount of drinking. We do a lot of drinking because it is Europe. You're allowed to put drinks on your expenses. Thanks to the French. Yay. If you thought that was tricky, we're also implementing something called the European Open Science Cloud Life Project. But Carole, you just dissed the European Open Science Cloud. Yes, I did, but it's funding me, so hurrah. It is 6 billion euros, so hey, small change. And here we are taking all of those different resources, the hundreds of data sets, hundreds of tools, and it's one of the 13 research infrastructures just like it that we're going to put together, and we're going to build a commons of commons in order to be able to put together all of the catalogues and all of the data sets and all of the tools for things like biobanking and marine and systems biology and plant phenotyping. It'll be great. So that's the situation I find myself in. So the first thing I want to, before I go into building fair commons and the pain, actually it's mainly pain I'm going to express. This is a multiple therapy session I'm doing here. I'm going to do a fair threat. Now, I'm one of the authors of the FAIR paper, the FAIR Guiding Principles for Scientific Data Management. I think you are as well, Phil. So this, again, is my personal opinions. There were many efforts before. It was a grassroots activity that became a viral activity and has become a bananas activity, actually. So this comes out of a workshop that we had in the Netherlands. You'll see it everywhere. So who's heard of the FAIR principles? Hey, you're doing better than many folks. It's kind of a feature of NIH policy. It's a feature of European policy. There's a whole bunch of, G7 has policy, OECD has policy. It's everywhere. There's papers about it. So in molecular plant here, we have a paper. Human genetics, are the FAIR guiding principles good? There's a shed load of projects with the word FAIR and a noun or a verb attached in order to be able to get funding. But who's read the FAIR principles? Okay, that was fewer people than heard of them. I see Jessica at the back has actually read them. This is what they actually are. To save you reading them, it says that data and metadata have identifiers, they have standard protocols, and they have least restrictive licenses. They have machine-readable data formats. They use community standards that are persistent, and they tell you about the provenance of the data and how it's been cross-linked to other data. That's more or less what they say. The key point here is machine processable metadata. Okay. So there's a whole bunch of different infrastructures that are available for being able to find and access and interoperate and reuse. You know, the Interoperate Genomic Toolkit from the Global Alliance for Genomics and Health, for example. BBMRI ERIC is a directory of biobanks in Europe, and so on. Familiarity of the principles, though, you did better than normal, because this is the biology one. This is I'm familiar, or I'm very familiar. This is I've heard of them. This is I've no idea what they are. This is a sense of self-reported compliance. Yes, I am very compliant. I'm pretty compliant. I'm not very much compliant. This is actually probably a lie, because I don't know anybody who's compliant. I'm not compliant, and I wrote the bloody principles. So, because it's actually very difficult. So, so now we're hearing we are and always will be and have always been fair. Our technology is the right technology to be fair. Only we can control fair. We don't know what it means, but we want to measure it anyway, and we want to certify it. And these are simple words, and it is a simple word. Before that, we used to use all sorts of complicated words, but it took a Dutchman to come up with the notion of fair as a very simple word, because I could say to a politician, we're going to make our data fairer for science. And they went, cool, that's good, have some money. So that's what we did. Simple ideas are not the same as simple realization. It's not a fuzzy feeling. So lots of people are interpreting this as a fuzzy feeling. It's the ability to enhance, or the ability for machines to automatically find and use data or any digital object. That's all to do with access and reproducibility and automation. That's actually quite challenging. So the principles are also, they were never intended to be a standard. It's not a standard. It's an aspiration. It's a vision. It's a bunch of people sitting in a bar in Amsterdam drinking. Okay, this paper, for those of you, Jessica's read it, the FAIR principles are only described in a breakout box. That's it. They're never explained. They're just listed in a breakout box. And this entire industry has been built on it. It's quite scary. They're ambiguous. They're a spectrum. They are only a subset of the indicators you need. They're really about setting up a set of behaviors. They're not a standard. They're not about humans. They're not strict. They're not for just one domain. They're not one size fits all. They're not tablets of stone. It's not the same as open, right? Because there's many times you cannot be open. If they were open, it'd be called for, not fair. We won't be able to say it. And of course, many of the things that we've heard about today, from precision medicine and so on, need access to be controlled. I work in a lot of industrial biotechnology. That's really, people are really scared to have their data available in an uncontrolled kind of way, because they have intellectual property associated with it. From Europe, we're in the land of GDPR, trying to work with particularly German hospitals. That's damn hard to get hold of data. So really, open is not the same as fair. They're not about quality. I can have a fair data set, which is basically rubbish. But it has machine processable metadata and adheres to a standard. It just doesn't have very good content. And it has very little scientific value. It's not about harmonizing all the metadata to a schema. So that's an unsolved problem. Yes, interoperability is a confusing description. It doesn't mean publishing everything as research data framework, for those of you who are from the semantic web, or reality distortion field is another way of talking about it. It's not all or nothing because you're expected to be incremental with it. It's not one size fits all. And there's this famous cartoon about everybody has to take the same exam, please climb the tree. So if we had the same fair indicators for everything, we would be being unfair. There would be no level playing field. And that absolutely does matter. So why does this matter? Because as soon as you come up with an idea that policymakers really get hold of, they want to have indicators that something really is fair and that there's something that they can measure against. So we originally, the whole idea of this was to set up a sort of contract by being able to describe what was there. We would be able to move the community on to have better self-evaluation, better reporting. We would be able to build some better comparisons and monitoring by having good quality metadata that was machine processable. And of course, it assumes the existence of standards and vocabularies and all the infrastructure and the capability to be able to be able to implement this. So, okay, let's try to figure out what these indicators might be. Let's take the easiest one, a user license. Is there a user license? What's the nature of the license? What are the terms of the license? What level might the license be? Level 0, there isn't a license. Level 1, it's a non-standard license, but it's only human readable, and so on and so on. So these kinds of indicators are currently being developed by the FAIR Data Maturity Model Working Group of the Research Data Alliance. And it's taken them 2 years so far to not be able to do this, because it's quite tricky, because it's a spectrum. They're contextually dependent, they're community specific. A library's viewpoint, quite a lot of this is driven from the library community, is quite different for a genomics viewpoint. So a library, for example, will demand that you must have the funder associated with your data set, otherwise it's not fair. Whereas somebody from a scientific background may not actually care very much about that. And also, what's the cost benefit? Because this is actually expensive to build. So we cannot shortcut communities to define appropriate maturity levels with these indicators because it's non-trivial, it's domain-specific at anything other than the most superficial level. However, there's been a all-out drive to do judgment and regulation with a whole bunch of organizations around this attempting to do this. Why does this matter? There's an entire industry being set up now around evaluation services, evaluation businesses. Here, we're beginning to get collections where there's a markup to say how fair a data set is. And fairness equals funding. So as soon as you get some notion of, well, I'm judging this data set, then you're having an environment where you're creating a field of for policymakers to be able to make decisions about who and who not to fund. Does that matter? Well, this group, the Research Data Alliance, which are defining all of this, has been set up by the European Commission as a PricewaterhouseCoopers contract. And at the end, they will decide, and we will help them, what is fair, and then that will be how things are judged. Right? So if this happens in Europe, it's going to happen elsewhere. RDA is also, US is part of RDA too. So this is something to worry about, I would suggest. And something else that we've been doing as part of the Elixir program is trying to, through a project with the European Commission and a collection of pharmaceutical companies, look at what does it really mean to take data collections that have been developed with pharmaceutical companies in public-private partnerships or within their own organizations and figure out what would a maturity model be, what would a verification methodology be. And yes, verification is a real word. I didn't make it up. What's the cost-benefit analysis? So let's look at this. Metadata identifier resolves to a metadata record. What is a metadata record, people? How is that different to a data set? Data complies with a community standard. How do you know it does? What if there isn't one? What happens if we use a de facto standard and not the real one? And it turns out, when you really look at these data sets held by the pharmaceutical companies and their colleagues, it's a complete mess. Chaotic identifier use, shifting indicators, licensing. 2 years we've been trying to get hold of one of these data sets, and the licensing is just a nightmare. So the moral of this is, first of all, be very careful about when you choose your words. That's the first big moral. Second is responsible fairness. We need to really think carefully about what we mean by fair, and fair is not free, particularly from the point of view of our funding organizations where they want fair data, but they only want to support research. So that's my rant. And I don't know if you agree with that rant, Phil, or not. Pretty much. Yeah, it's a kind of, you think we've let the genie out of the bottle a bit here. We didn't expect that this would be quite so rampant so quickly. It feels like we've lost control of quite a dangerous concept. But anyway, let's get back to trying to do some actual real work. So the first piece of real work we've tried to do in this, do you remember? I said we had this complicated environment, lots of data sets, many of which we don't particularly own. Well, the first is we've tried to do universal findability and ubiquitous markup. And for this, we have leveraged Google and all of its friends. So here we have developed something called bioschemas, which effectively is conventions for using structured metadata markup in web pages. Very low barrier. It means that we're able to find metadata in a web page, harvest it without an API. And we can use this to register and index data collections, move metadata between resources. We can do automated curation. We can do markup for tools. We can feed the knowledge graphs that were mentioned earlier. And we can do some of that fair stuff. We can actually mark up to say something has a license or not. So for the past 2 or 3 years, we have been developing as a big consortium in Elixir markup for describing what is a data catalog, what is the training material, what's a lab protocol, what's a sample, what's protein structure. And then using this markup in a very lightweight way in order to be able to feed registries, to be able to feed search engines, and to, for example, move metadata from databases which are managed by very few resources into big aggregators. So this has ended up being 14 countries and 300 people involved in this. And we have a limit of 6 concepts per thing. So this is really scruffy semantics. So I remember working in the semantic web wars and the ontology wars that were mentioned earlier. And we would argue for months about one particular concept and reasoning over concepts and so on. This is really scruffy semantics. This is not clever reasoning. This is not OWL. This is really lightweight stuff. And in fact, we had to really fight in order to be able to avoid ontology-itis, where you end up having arguments about how many angels on the head of a pin for a particular concept. This is rough and ready indexing, building consensus around it. We have a lot of catch-22 in it. So schema.org is an organization that manages the actual terms that are recognized by that organization. They want to see the use of our conventions, and basically it's just reusing theirs, but in a particular kind of way. And they want to see it, but then we need it to be there before we can get people to use it, and that's caused a lot of difficulties. But we currently now have about 20 million pages marked up and 80 sites. So this is really exciting. So this is actually a mechanism of moving metadata between commonses, across at scale. So this is metadata at scale. And our next efforts are around annotating rare disease registries and intrinsically ordered proteins and plant sciences. The next thing that we've really worked on in Elixir around FAIR is computational workflows. As Larry mentioned, I've spent a long time doing workflows. This actually isn't the Death Star, although it does look a bit like the Death Star. It's from a European report, so maybe it is a Death Star. It mentions here digital objects. So this is software models, workflows, scripts, standard operating procedures, lab protocols, anything, not just data, is the digital object that will have metadata, that will have standard formats and will move around our commons. So this is an example of a workflow, chains of codes, data and control flow, and engines associated with it. And we have a lot of this in Elixir. We have it for human data, we have them for cell transcriptomics, we have it for metabolomics, and every kind of area that we work in, we have workflows. So we have a workflow management system and registry zoo. How many workflow systems are there that are more than just the fevered imagination of a PhD student writing a paper, i.e. have a GitHub and related? Does anybody want to have a guess? Actually in working use today, as of this list here. 20? 200? 50? 266. So 266 workflow systems that we know of, and here's a small collection of logo clouds of those. For the last time I was here, I was talking about my experiment, which was a workflow commons, a place where we put workflows as commodities in their own right. And we're now redoing this as a workflow hub for life science workflows for this new Elixir project. So this is a real zoo. But this is actually a great opportunity, because now we can see that workflows from the last 20 years, workflows have really come along as a core resource, as a core kind of technology. And they're absolutely critical for FAIR, because they both generate machine processable data, machine accessible data, but they're also very much needed. You know, FAIR data is needed in those workflows, because remember, FAIR was all about machine processability, and this is all about machine processability. And if we're going to scale, we need machine processability, we need these kind of workflows. We can treat them like data objects, and we can also treat them like software objects. Like data objects, we can just treat them as if they were any kind of FAIR component. Software objects, it's a different game altogether, because we're talking about versioning and executability and all sorts of issues around software which are completely different when one is talking about software as opposed to data. But the opportunities here are very exciting. So this is a piece of work by Rob Finn in Elixir, and this is building workflows as collections of workflow blocks in order to be able to support his Magnify metagenomics pipelining. So these are all very well described blocks. Those blocks can then be versioned and comparisoned. We can recycle the tool descriptions associated with them. We can recycle sub-workflows. We can build, in fact, not just data blocks now, but process blocks. And there's a very nice paper that came out in Nature in the summer that describes how by describing workflows in this way, two different sites, the Magnify site and the MGRAS metagenomics community in Argonne, were able to exchange and compare their pipelines, although they were using completely different platforms. One was using an IBM workflow engine, and the other one was using the OR workflow engine. And the reason we could do that is because we've got standards. And if we're going to build a commons, we need standards. So we talked about bioschema as a standard for being able to exchange metadata and find metadata across a commons. And here, this is a standard for being able to describe workflows. So we can describe the inputs and the command line tools and the containers associated with those tools and the outputs. And this is the stack that we use in Elixir. And in particular, we use this thing called the Common Workflow Language. So we do a lot of work on portable packaging. We have many different kinds of workflow systems. We have many different kinds of repositories associated with those different kinds of workflow systems, but we can standardize the way that we describe things. So one of the things we've really fostered in building our FAIR Commons is being able to describe workflows in a portable and interoperable way, and being able to package all of the different components of a workflow, the data, the references to files, the provenance, the list, the log of what actually happened, related data collections, and so on, all together in this packaging framework that came from a project a long time ago. Again, what was the pain? The pain is ontologiitis. The tendency to want to do things beautifully, elegantly, using very rich kind of semantic web type of technologies, when actually the right thing to use is JSON. Just really simple environments. And we had to wait until the digital library people told us to do that, because a tendency is always to do things in a very complicated kind of way. And of course, building consensus and getting buy-in. This approach is now being picked up by something called biocompute objects. And biocompute objects combine a whole collection of standards in order to be able to describe in a safe kind of way high-throughput sequencing pipelines for the Food and Drug Administration. This is work with the George Washington University. So what this does is describe in a very rich way the parameter spaces of a process, of high-throughput screening process, all of the different components of it, so that this can be regulated as an instrument by the Food and Drug Administration, just like it regulates all kinds of other instruments. And this is going through a standardization activity right now. And we're using these languages in order to be able to put that together. I've been working on this thing called this research object framework for a very long time, for over 10 years now, a way of being able to package together components, package together the things of science, the data, the files, the models, the workflows, the scripts, the publications as units, as things that could be worked together so that we could then be reproducible. And it's taken forever to be able to get through, to be able to have this really take on. It's because it's difficult. It's difficult to change how we do processes. So in particular, I see this as a big vision. This is our big picture. The notion of no longer worrying about exchanging papers, but instead we exchange units, components, collections of the results of research. And the research object is the mechanism of being able to do that. And one of the reasons it can do that is because it's a framework for being able to organize the contents, organize things and put them together with references to external stores. So I can package together a set of standard operating procedures and presentations and data into a unit and give it a DOI, and I can ship it off to a different kind of store. But the things it references can be held somewhere else, and that's very important when you have a distributed commons. And this approach has been picked up by people in the cancer cloud environment. So, for example, if you have a complicated set of collections of data and you cannot move that data around, but you want to talk about that data as a unit, then you can use a research object in order to be able to package the content of that as a metadata object to refer to the various different components and exchange that. And the same in the Seven Bridges Cancer Cloud. Here, all the different components can be packaged together and deposited in a resource like Zenodo. So finally, so the final piece that we have to worry about in our distributed commons is that we have been very good about building a very kind of rich environment for elixir, a rich collection of archives. Each of our countries, each of our facilities has a rich collection of its own stores and its own resources, but we still have the poor researcher up here who is, well, how do they use this? How do they get their results organized? How do they get their data organized? Because there's completely different incentives at these various different levels. And this is what we call the first and last mile. So we can build a very rich collection of archives, but if you can't use them, if you can't get to them, you can't put your results into them, it's really difficult. So we've used something that we've built for a long time now called a Project Investigator Commons, which we built for systems biologists, actually, who were self-managing their own results. Again, they were in competing and collaborating teams, and they just wanted to organize and share their resources. And because they were systems biologists, they were using models and data and scripts, and these all needed to be stored in their honorable places, so they had to be stored in the correct public archives, biomodels for a model, PRIDE for proteomic data, and so on. But we wanted to be able to keep what was actually the context of that experiment together in one place. And this is what we managed to do by bridging this ecosystem by having a integrated view in the commons. So, for example, here's a project, here's all the different kinds of components of it, and some of this data is in a public archive, some of it's in a secure store, some of it's in a local facility, and so that you're able to build an overarching connection between all the different resources in elixir, as well as keeping the context of what it actually means to the actual project itself in a controlled way, so that these different areas, I can only see the things that I'm allowed to see, and that's really important. And then I can version that, snapshot it, release it, and so on. Because what we want to be able to do is to release our research rather than just publish our research. So I'll skip that. So there's some interesting observations here. We spent the last, 12 years supporting collections of people using this environment, this FAIRDom environment. It was originally built in order to be able to have projects be able to find out who was doing what and be able to share important information between the different partners in the different projects. So these are all partners who are all typically distributed, because it's typically European projects. They're distributed all over the place. And so we wanted to be able to have a place a commons place where we could find all of the different information for those partners to be able to share their results. So what did we learn from doing that? Well, the first thing we learned was co-development, and a lot of drinking again. We did a lot of drinking. Keeping everything simple, And we had a lot of trouble getting our particularly PIs in order to buy into the notion of data management. So that was really tricky. And one of the particular things we had with our developers was their tendency to want to be able to do the perfect. So so this is the jam today, jam tomorrow model. Can you pass the jam? I said, I know I'm developing a system to pass arbitrary spreads. It's been 20 minutes. It'll save time in the long run. So this doesn't work with people who need to be able to get their results out. They need to get their paper published. It's just enough, just-in-time development in order to be able to build this environment in a shared, developed way. The second thing we learned was low-tech works. So we did a lot of spreadsheet tools. We do a lot of metadata auto-magic. So we do a lot of extracting of metadata automatically. We employ choice architecture, a libertarian paternalism, which means tricking people into being able to do things that they didn't really want to do, but you trick them by stealth. We didn't say, when would you like this, do you want to have this content publicly available? We said, when do you want to have it citable? It's a completely different choice. That's choice architecture. We had to do a lot of professionalized stewardship. We had to recognize that a lot of our researchers effectively worked in sweatshops because they do. Their science has become a bit of a sweatshop. And this tool, for example, hides ontologies into a spreadsheet so that you think you're using a spreadsheet, but actually you're using a very rich knowledge environment. It just looks like a spreadsheet and quacks like a spreadsheet and waddles like a spreadsheet and therefore doesn't frighten anybody. We also really had discovered issues to do with public good versus personal productivity. So really, so the whole notion of community socialization and the values of sharing, particularly amongst PIs, is really hard work. Postdocs are very keen to participate and donate data and to be able to share and collaborate. PIs much less so. And really it's because partly you're working for strangers, but you're also working for rivals. So that was incredibly tricky. And the amount of metadata that you need in order to be able to be fair radically increases the more strange you are. This Barcelona riot is a particular project where we had a meeting in Barcelona where there was an attempt to organize how to share standard operating procedures. And it was a riot for 2 days. There was blood on the table because people really didn't want to share their standard operating procedures, despite the fact that they were a set of facilities. And the only way you're going to understand the data is if you share your standard operating procedures. And they're even paid to do this. Once we changed the name to Lab Protocol, everything was fine. So there's real issues around the names of things. And we have challenges around when we're building our commons and versus the actual personal view of the people who are using that commons. Our commons is about sustainability and reusability, and the users are particularly keen on productivity and quick and lightweight solutions. So you get this kind of tribal creep. We saw a lot of data hugging, where the data, you hang on to your data, a lot of data flirting, where you show a bit of the data, but you have to, take me on a date to see the rest of the data, or, put me on your paper. The further away you get from my team and me to people away from you, the further away people are, the less likely you are to share. Very poor reciprocity, so people are very happy to, if they do share something, people are very bad about citing it. So this is all a bit depressing. it's all a bit of the pain is quite tricky. So, because there is a bit of a tragedy with the commons, and this is a picture from Brian Nosek from the Center of Open Sciences, where he sort of says that this is what we're trying to do. We're trying to build infrastructure to make things possible, and we've got policies that make things required, but in the middle, we've got to make things easy to use, we've got to change culture, and we've got to build incentives. And this is all social stuff. This is all difficult stuff. Technical infrastructure is straightforward. Asserting policies, as we've already seen through FAIR, is straightforward. Changing cultural norms is much harder. Because in the end, there's only really 4 forms of incentive: love, money, fame, and nudge. And so love is what PhD students do until they become faculty. Fame is citations. Money is funding. Nudge is choice architecture, libertarian paternalism, where you basically pervert or perturb a system in order to be able to change behaviors. And I've come to the conclusion that love is very nice, but it doesn't last beyond postdoc. Money and citations and fame are very fragile. Nudge, we're going to have to do everything through understanding how can we do subtle changes to the system in order to be able to change behaviors. I used to believe in carrots, and now I believe in sticks. A long time we've had data sharing and data citation, so who's cited data here? You're very good people. And you're very unusual. So I just don't believe in it anymore. I just believe in mandates. So mandates are going to matter. And let's make sure they're the right mandates, otherwise we end up with some strange behaviors, of course. So what do I expect to see in the next 25 years? Well, this is, I expect to see jet packs, of course. I don't quite know why I haven't got a jet pack yet. What do we have 25 years ago? What was there? Well, we didn't have Google or Wi-Fi or crowdsourcing or precision medicine or another wave of AI. I remember this is the 3rd wave of AI because I'm quite old. We didn't have cloud computing, we didn't have smart devices, we didn't have big data. There was quite a lot of stuff. It's amazing that there was a conference at all because there was hardly anything worth talking about, really. So what are we going to have in the next 25 years? I think we're going to have wide use of commons platforms, and we're going to have research development toolkits. AI, we're going to put to use in order to be able to support research data management rather than just sit on top of the results of research data management. We're going to have professionalized data stewards, professionalized research software engineering recognized. We're going to have FAIR first, once we've sorted out what the heck FAIR means, and reproducibility de facto, particularly because we'll be using development toolkits. We'll be taking these research, we won't be publishing papers, just papers, we'll be publishing research objects, or we might call them notebooks, directly out of our research environments. We'll have knowledge graphs of those research objects. We'll have clever microcredit systems in order to be able to give credit, particularly when we're working in teams. We'll have an understanding of team science, team methodology, team technology. Team science won't be just a bunch of people get together and we still judge everybody individually. It'll be about teams. We will still have Excel spreadsheets. And I very much doubt that we will have managed to change the incentive and assessment models of science because there's such a cultural inertia. So I think one of the things I realized when I look back on what happened in PSB, all the changes were technical. All the things were to do with new technologies, but actually the social frameworks around those technologies didn't change. And in the next 25 years, I think the same thing's going to happen. We're going to have a lot of technical innovation, a lot of change in the way that we disseminate knowledge, and we won't have changed at all the social environment unless we can do something about it. And that's a pain. So that's a bit of a downer. So on that down note, I want to thank you for inviting me. I'm sorry I didn't do it in iambic pentameter or any other kind of poetry. If I'd have known that, I'd have tried to do a cat in the hat. And I want to thank everybody for listening. I hope that you learned something. I hope you've been inspired. I hope you'll be skeptical of FAIR. I hope that you will be enthused in order to be able to help us on our FAIR Commons journey. So thank you very much.
Slightly over. Can we ask questions anyway? Sure. Okay. Thank you, Carole. That was awesome. I wanted to ask you about something that's a little bit beyond what you talked about, of when we make data fair and accessible and available. Something that my org is struggling with is that the owners of it, or the originators of it, number one, want to make sure once they share it that they know what happened, and number two, want to facilitate and give that sort of additional metadata that may not be represented all the time. And I can imagine a spectrum going from laissez-faire, here's the data, throw it over the wall, you never get it, to much more rigid, you must sign it out and you must say what you're going to do and here's all the things. And neither of those are ideal. Do you have any recommendations? Is anyone doing this well? Are there any good models for this?
Oh, that's a really good question. So there are folks that are thinking about that quite a lot, particularly in the Research Data Alliance. I don't know if you participate in that, Jessica, but there's this notion about very strong regulation around FAIR. So, you know, you really want to tighten it up, keep it really tight, versus very loose kind of anything can hang out, and then progressions. So the whole notion of a kind of FAIR maturity model that you move through with different levels is exactly what we're trying to do in the FAIR Plus project. And I'm particularly seeing this in the pharmaceutical space, that pharmaceutical companies are working on what does a capability model mean. There's actually work being done at the moment by Pistoia Alliance, for those of you who are familiar with that, which is a vendor organization around pharma. And they are producing a FAIR toolkit, which is in order to be able to basically say what level are you at in your current data set, what level do you need to get to, and what are the stages that you need to work through. So it's a bit like software maturity models, but this is for FAIR maturity models. So those are the things that I've seen.
Okay, I'll check it out.
So I think but it's slow work.
Yes.
It's slow work. Yeah.
Thank you.
As far as kind of changing the community and encouraging adoption of what's already out there, even if it's just the low-hanging fruit and small changes people can make, it seems like the scientific journals definitely have a role they could play in promoting this. I've had this fantasy for some time now where scientific journals, in addition to, you know, hiring or soliciting kind of peer reviewers, they would also get someone to review specifically code and data and at least, you know, mention small changes again people can make to improve this. That's also not likely to happen because, you know, it's not probably in the journal's own incentives to do this. Some do, yeah. So there are the data-specific journals that actually promote that, and that's fantastic. How about, in order to kind of wrestle control of some of these things out of the journal's hands, though, what about creating something like a manifesto where, as peer reviewers, we can sign on and say, here's some simple things I'm going to check and at least mention, and we don't have to enforce it, say, you know, this article's trash because you didn't share your code on GitHub and use data package standards or whatever. But at least they could kind of point the authors in the direction of some small changes they can make. And this is something we could do. You could have a very short manifesto and some best practices on a web page.
Yeah, actually there's a bunch of activities around that. There is the reproducibility manifesto, there's the science code manifesto, and there's kind of a manifesto of manifestos, actually.
Yeah.
So there's a lot of manifestos. The point is getting them into use.
So why not twist some arms at this conference? Because
Yeah,
I haven't heard of any of these before.
Yeah, there's quite a lot of activity here. Actually, Cascade is the first thing that I've seen, which is really towards this. So that's the French system. It's an agency, so it's actually funded by the French government in order to be able to check whether your code, for example, and your data is available and your code is reproducible. Yeah. And by reproducible, they mean, can I get hold of the container and actually get it up and run it? You have to get a reproducibility ticket before the journals that have signed up to that will accept the paper. Yeah. So that's the very first thing that I've seen in that area. It's caused a little bit of a ruction because the people who are checking that aren't domain specialists. Yeah. Right, they're just going through the mechanics of it. So yeah, they can get it up and run it, but they don't know if it's any good. So there's two different steps there. Can I actually get hold of stuff, and is it any good? And they can do the first step, but not the second step. The second step requires proper buy-in from peer review in journals. And we all know that trying to get somebody to peer review a paper is really hard. Now we have to get them to peer review the code or something else. That's like, you're never going to get a paper out again, which is why journals are very reluctant about it. Publishers are very keen. Journals are very reluctant. Don't confuse publishers with journals. Okay, publishers are all trying all sorts of things. Nature have promoted the notion of code ocean. They're trying to do all of these different kinds of things. They're very unpopular with their journal editors because it's a barrier.
Thank you.
Yeah, but we can talk about manifestos. Yeah, I can point you to some.
Yeah, great talk. I had a question. How about that? Which follows right on with that, which is, what is the role of funding agencies in providing carrot/stick? I mean, can you think of a post? So rather than the funding, NIH, for instance, requires data sharing statement, but I think some of that is lip service. What about enforcing that in some way through funding agencies?
Yeah. I used to work for a funding council in the UK for 5 years, and again, it's a fear thing, right? So the funding councils are very good at setting policy and very bad at following up with policing. And what you want is police. And this is kind of where I think, in the end, we have to get some teeth into the policing movement. Enough of carrots, more sticks. When people are required to upload data to archives because they don't get the paper out otherwise, suddenly they all can do it. And before that, they couldn't do it. That means that the funding agencies have to do more than just do rhetoric around policy. And they're always, my experience is, a little afraid. They think it's the community's job to be able to do that. The community will never do that without an external driver in order to be able to push that. And in particular, the organizations and the institutions that researchers work in won't provide the support to do that, because the researcher might be keen on it, but the institution or the lab manager or the director of the institute will say, why are you wasting your time doing that when you could be putting me out a Nature paper? So I think that there has to be a kind of major shift in the value that one associates with data and the value one associates with software in order to be able to say we're actually really going to follow this through. Now, I have seen some examples, and I think it's important for us to personally take action. We sit on those panels, we sit on those research committees, we sit on those promotion boards, and I've seen the enemy and it is us, right? So when I sat on a committee that assigned panelists to review grants, and I was assigning people to it, I ignored their impact factor of their journals. I ignored whether they were a PI or a CI or not, because informaticians are nearly always in the middle of a paper and nearly always a co-investigator, not a prime investigator. I ignored the fact that they hadn't got a PhD, but they were a facility manager, because we needed a facility manager to be able to review the awards. So I actually did what I said I would do, and it made me very unpopular, and I didn't care, because I'm old and I've got tenure, right? So nobody's going to fire me. So I think it's up to us, those of us who are old with tenure, to try to do these changes in order to be able to help those who are still struggling up the slippery pole. That was a long answer.
As someone with old with tenure, yeah, it's a struggle. I mean, just if I could comment just quickly on that particular instance. I mean, we wouldn't dream of publishing a paper without acknowledging the funding source in that paper. We could just as easily make that a piece of metadata that goes, at least when data goes into repositories, so which could easily be retrieved. So when data was put into a repository, the fact that that had been done, the funding agencies would know that, and it would close the loop about in these data sharing policies, which doesn't happen right now.
No, you're right.
In my 3 years at NIH, I tried to make that happen. Too conservative to get it done, but it'll come around. I just wanted to, one thing you didn't mention, I just want to ask about was, or really in any detail, was the influence of other disciplines. Now we're all in this data science mode.
Oh, yeah.
Is that going to create more chaos, or can you see as we evolve that what comes from other disciplines will actually accelerate all the wonderful things that you describe and you're doing yourself?
So that's very interesting. When I was looking at the survey of who understood what FAIR was, the people who most understood were from the humanities. So that was quite interesting to me. So I don't know what that means, but I do know that there are other disciplines that are very looking out and saying, how can we be much more collaborative? How can we actually, how can we adopt some of these principles in a positive kind of way? The least aware were physicists, which is kind of surprising, because physics for a long time has had a very good sharing kind of culture. So I think there'll be some interesting areas. I think so I'm not quite sure. To be honest, I don't know. We'll have a talk later on, won't we, from a social scientist. Social scientists, in my experience, are great at telling us how we should do libertarian paternalism and sort of being able to do social engineering, which is what effectively I do, and a bit mixed when it comes to sharing their data. So I'm interested to ask her what she thinks.
I mean, if I may just 1 second, I mean, there is this opportunity, it seems, because just in the US, there's at least 200 data science initiatives going on in institutions, a lot in Europe as well and elsewhere. And they themselves are sort of aggregators of what's going on in the humanities, the social sciences, the physics, and all these other fields. And they then become projectors of what might be the best practices in some of these things that we didn't have access to before. And that might accelerate things, but it might create more chaos.
That's that would be a really useful thing of the European Open Science Cloud, if it actually disseminated best practice and showed us different kind of techniques amongst different communities. So that's a good point, actually.
Right. Thanks, Carole, for your enthusiasm and for expanding my vocabulary to include terms such as libertarian paternalism and data flirting, because those were not available to me until today. Thanks so much. So my question is to get more concrete, is basically on behalf of a friend who's a brilliant systems biologist who has the opportunity to start a whole new lab in the coming year. And I'd love for her to be able to be part of all this in her thinking, but brilliant as she is, she's going to be focusing on setting up this small sweatshop and continuing to publish. So what is a baby step she can take to get going on this?
You mean from a practical step?
From a very practical, like,
Yeah.
I mean, does she hire a postdoc and have that postdoc focus on this, or a technician?
So
or?
I would hire somebody who was actually to be professional, to have somebody whose job it was. You could call them a research software engineer, you could call them a data steward, you could call them a data scientist, you could call them what you like, but somebody whose job wasn't to write papers.
Yes.
Their job was to enable you to write the paper. And this whole professionalization, I think, is absolutely critical. So within my own university, 6 years ago, we had nothing like this. Now we have a thriving pool. We have 40 research software engineers who we can call upon, who we can hire into our projects, who will take code and make it go fast, take code and link it together, data stewards who will help us with our metadata, people who actually, their job is just to do this. And the effect has been transformative, I would say. So, but this is like an old idea. It's the technician idea. It's the staff scientist idea that somehow fell out of favor, which seems a bit crazy when this is the time we really need somebody like that.
Yeah, because I think she will be more successful if she does get going on this sooner rather than later.
Yeah, exactly. Right from the beginning. Do it at the beginning because you'll need to get the processes in place. And once you've got the processes and you've set it from the top, you must set it from the top. So the projects that I've been least successful in are where the people at the top really did not believe in data. They did not believe in the investment needed in order to be able to do that metadata management, to do that careful stewardship. And later on, 2 or 3 years later, they say, oh, but Carole, we can't get hold of that data. Well, yeah, because you didn't do it. You weren't interested, and you cut us out. In fact, you banned your PhD students and your postdocs from doing the processes that have been set up. I won't tell you who they were, but I don't work with them anymore. Because, there was lack of respect there. So you must do it at the beginning.
Hi, thank you for your talk. My question is, what are your thoughts on the topic of software and data maintenance? So I think that's a big challenge, especially if you're in a small lab. If you publish a database or if you publish some software, you don't really have that much of an incentive to maintain it and update the database with new data that comes in, or respond to issues on GitHub or add new features. And so what are your thoughts on incentives for promoting that and just that topic in general?
Yeah, that's a really tough topic because you could set up a piece of software or data in order to be able to be as a proof of concept, or just because that was the mechanism for you in order to be able to demonstrate what you were trying to do, but it was never your intention to be a service provider. And suddenly you wake up one day to discover that you're a software purveyor, and you've got people from countries you've never heard of emailing you rude messages because they can't use your software, and they're not even paying you. Yeah, been there, done that, got the t-shirt. Particularly, you could start charging. People are much more respectful if you charge than if you give stuff away for free. That's just an observation. There are a number of different things that you can do. You can attempt to be able to follow a software sustainability framework. And if you go to the Software Sustainability Institute website in the UK, there's a whole bunch of guidelines and techniques in order to be able to help you do that. So it's how you kind of set up at the beginning so that you can have sustainable practices right from the start, or at least early on, so you don't end up doing it late on. Doing it late on is really hard. If you can kind of set it up at the beginning, it's a lot easier. And it tells you about those kinds of things. Sometimes you just have to say no. right? So there's, you know, not all software will be sustainable. Not all data sets will be maintained. And that's just the nature of the beast. Things will be sunsetted. 266 workflow systems. I reckon about 25 are actually usable, right? The rest are GitHub tombs.
Thank you.